Okay, let's talk probability. Okay, so let's start off small. Let's talk about tossing two coins. There's no figure. I kind of got that word, but there are 4 different ways the coins can fall. Okay, so let's say you get a heads for the first coin. You toss it, you get a heads. Okay, and then you're going to toss the second coin, and that second coin could also be a head, right? Good. Well, if you toss the first coin head, the second coin could also be a tail. Okay, so there's 2 different possibilities. You have a heads and a heads. Or you can have a heads and then a tail. Okay, well, that's if you get a heads first. Well, what if you get a tails first? Well, you get a tails first, you could get a head second, or you get tails second. So you have heads, tails, heads, or tails, tails. Yeah, so this is a tree diagram. We'll talk about that in a minute. So there are, 4 ways that this could result. Note that this and this are different, because you got a heads first, here you got a tails first, and the 4 of these are what are called outcomes. These are the most basic possible results. In this case, right, we have 4. So because this is like the actual thing that happens, what actually happens, right, it says so HT is different than TH because this, you got heads first, then tails, you got tails, then heads. Those are 2 very different things that happened. Okay, but if we talk about an event, then we can talk about, just a category, a quality, a situation that we want to have happen. So for example, we could talk about not getting any heads. So if we look at our 4 possibilities, how many possibilities can we just don't get heads at all, which means both of them were tails, so there's only one outcome of these 4 that satisfied this event, that satisfied this situation. Now, how many times or how many different ways can we get just one head? Well, we could get the head first, or we can get the head second. So there are 2 outcomes that satisfy that situation. Okay, event 3, 2 heads. So we get a head first, and then we get a head second. That's the only way we get 2 heads, so that is only one outcome. And note that these are all your possibilities. There is no other possibility for heads that you can get. I mean, there are other situations you can talk about. You can talk about tails. You can talk about like having different ones on each one. If you're talking about the number of heads, all 3 of these encompass it. And so all 3 of these encompass it. This should add up to your total. Whoa, I don't know why I put total number of outcomes, which they do. 1 plus 2 plus 1 is 4. Okay, so now we talk about events and outcomes. Now we want to use these to figure out the probability. So the probability, of course, is the chance that something is going to happen. So we write that as P of our event, whatever that event is. Usually we call it by A, or we can just write in whatever it is. That probability is always going to be between 0 and 1, because probabilities we talk about in the decimal form. But in percentages, this is between 0% and 100%, which makes sense, right? So a chance of something happening is either going to be between 0 and 100. Now, 0% chance that something's going to happen is just saying it's never going to happen. There's absolutely no way that something is going to happen. 100% chance says it's always going to happen. It's definite, it's for sure, it's certain. And of course, the closer you get to 100%, the more likely something is. The closer you get to 0, the more unlikely it is. So, like talking about like rain. If there's a 90% chance of rain, it's probably going to rain. But if there's only like a 5% chance of rain, it's probably not. It still could, but it's not likely. And then, of course, we have our 50-50 chance. We call it 50-50 because there's 50% chance it won't, 50% chance it will. And so that would be your 0.5 or 50% right there in the middle. Okay, there are 3 types of probabilities. You have subjective probability, which is basically just your guess. This is based on maybe your past history or just your gut reaction. This is saying, my son uses this a lot. Like he's 70% sure that something's going to happen, right? That's just, something that you kind of pull out, whatever. We talked about that for like the pull from the air statistic. That's kind of what this is. And there's theoretical probability and empirical probability. So we'll talk mainly about these two. So let's first talk about theoretical. So theoretical is just based on the assumption that all outcomes are equally likely. So this is talking about like in a perfect world. Because in the real world, we have all sorts of things that are going to affect how something happens. So think about like a coin toss, the wind would make a difference, how old the coin is would make a difference, how we flipped it could make a difference, right? So there's all sorts of different variables. So this is just in a perfect world, this is what would happen. It also means like in the long run, and we'll talk more about this in the next section. Okay, so find the probability. Probability is like a percentage, so it's basically a part over the whole. You say the number of ways that satisfy your situation, satisfy your event, over the total number. So you're saying of all of the things that could happen, what's the percent that it does actually happen? So your part would be the number of ways it can occur, your total would be the total number of outcomes. Okay, so let's say we flip a fair coin 3 times. So our possibilities, we could get a heads first, and then second coin we can get a heads again, and third coin we can get heads again. So we'd have a heads, heads, heads. Well, I get heads first, heads second, and then tails third. And so as I'm following this, I'm taking like this line, this line, this line, and I've used that, so then I follow, I go back to my H and keep going to my T, to the H, H, T. Go back to H, can't go any further, so I go back to this H, and I'm going to go to the T and go into the H, so H, T, H. Go back to the T, continue on to this one. Now this one's done. Now this T can't go anymore, this H can't go anymore, so go back to this H can't go anymore. So go back and continue on to this T, keep going until I can't go anymore. T, H, H. Back to H, continue on to T. Now this H can't go anymore, back to the T, keep going. T, T, H. Back to the T, onto this T, so T, T, T. So that T is done, this one can't go any further, this one can't go any further, so I'm done. So I have 8 possible outcomes. And if you have a tree diagram, it's just going to be counting the number of leaves here on the end. So 8 outcomes, and this is everything that could happen. So what is the probability of getting 1 head and 2 tails? Okay, so we're going to count how many times we have 1 head and 2 tails. So really we just have to think about just 1 head, right? So this has 2, 2, this one has 1, so we have 1 and 2 and 3. So there's 3 possibilities of getting 1 head and 2 tails out of a total of 8. So my math lab may ask for the fraction, or if they ask for the decimal, you would do 3 divided by 8 and get 0.375. So the probability is 0.375. In your head, you can transfer it to percentage, saying there's a 37.5% chance that you will get 1 head and 2 tails. Okay. You can also think of it as, since you have 3, if you don't have like the list of things out here to look at, you can think of it kind of logically. So you only get 1 head out of 3 coins. So you could get that 1 head at the beginning. You can get that 1 head in the middle, the second one, or you can get that head at the end. And those are the only options if you only have 1 head. So there's 3. I have a total of 8. Now to get that 8, if you don't know how to do this, let's say you're flipping a coin like 7 times and you don't want to do all of this out 7 times. To figure this out, we use what's called the counting principle. Or figure this 8 out. So the counting principle says you take the number of possibilities for your first thing, multiply it by the number of possibilities for your second, and so on. So for example, we're tossing a coin 3 times. So we have 1 toss, 2 toss, 3 toss. Okay, so the 3 things are going to happen. So I have 3 lines. For the first coin, there are 2 possible ways that could turn out. It could be a heads or a tails. I toss my second coin, and there's, again, a heads or a tails. I toss my third one, and again, there's 2 for that one. So then I multiply all 3 of these together. 2 times 2 times 2 is 8. That is my total. If I were going to do, let's say I have 3 shirts, 5 pants, and let's say 3 shoes, and I want to make an outfit. Let's say they all match each other. Then so I have 3 things I'm choosing: shirts, pants, and shoes. There are 3 options for my shirts, 5 options for pants, 3 options for shoes. To get the total number of outfits, I would multiply all these together and get 45. So there are 45 different outfits. Okay, so that's just kind of an aside. Now let's go back to my coin. So the probability of getting 1 head is 0.375. The probability of getting all heads, well, that means you have heads, heads, and then heads. That only occurs once out of all 8. So it's either 1/8 or 0.125. Probability of getting no heads, well, that just means you have tails, tails, and tails. Well, there's only one way that can happen. You get a tail, tail, and tail. So that's, again, 1 out of 8, or 0.125. Okay, now the probability of getting at least 1 head. Okay, so there's a couple different ways to do this. So at least 1 head is very, it's kind of vague. It means that it covers 1 heads or 2 heads or 3 heads. So that would be a lot of counting. At this case, with a small, it's not all that hard. But note that it's either at least or none, right? So it's either this one or this one. And note what I said at the beginning, that when you have events that encompass everything that could happen. So here, it was either 0, 1, or 2 heads, right? Which means all of these had to add up to the total number of outcomes. Well, same thing here. It's either no head or at least 1, which means that the number of events that happen to this and the number of events that happen here have to add up to the total number of 8. So if one of them is 0 heads, that means 7 of them have to have at least 1. So the probability of at least 1 head is going to be 7 over 8, which is 0.875. So chances are good that you're going to get at least 1 head if you flip a coin 3 times. Now, if you have a small enough set, you can go ahead and count. So this has a head, so 1, 2, 3, 4, 5, 6, 7 are the ones that have at least 1. Okay, example 2. Now we're going to roll a fair 6-sided die. So what is the probability of rolling a 2? Okay, well, first of all, let's figure out how many outcomes we have. Well, if we're rolling a die once, we can either get a 1, a 2, a 3, a 4, a 5, or a 6. So there are 6 different outcomes. We can get one of all of these. So rolling a 2. Well, rolling a 2, there's only one option that matches that out of a total of 6. So probability is 1/6. Which is 0.16 repeating. Now if they ask you to round to the nearest hundredth, it would be 0.17. Well, the probability of not rolling a 2. Well, again, so rolling a 2 and not rolling a 2 are two opposite things. It's either this or this. So if there's 1 that's a 2, that means there has to be 5 that aren't. You can also count 1, 2, 3, 4, 5. So 5, 6 is 0.83. Also notice that these add up to 1. So if 1 plus 5 adds up to 6, these two percentages or decimals will have to add up to 1. So you could just subtract 0.16 from 1. Okay, part C, rolling a number larger than 2. Okay, note this says larger than 2, so we're not going to include 2. So we want 3, 4, 5, and 6, so that is 4 of them out of a total of 6, which is a reduced fraction is 2/3, and as a decimal is 0.6, or rounded 0.7. Or if we keep 2 decimal places, it would be 0.67. Okay, part D, the probability of rolling an odd. Well, odds are 1, 3, or 5. So that's 1, 2, 3 possibilities out of a total of 6, which as a reduced fraction is 1/2 or 0.5. There's a 50-50 chance of rolling an odd versus rolling an even. Okay, the probability of rolling a number larger than 6. Again, this is larger than 6, so we're not including 6. That would have to be 7 or above, which is nothing. So we have 0 over 6, which is 0. So there's no chance of rolling something greater than a 6. Okay, last one, probability of rolling 1, 2, 3, 4, 5, or 6. Well, that is everything, right? So there are 6 possibilities there. I have a total of 6. So probability is 1. So there is a definite chance I'm going to be rolling one of those numbers. Okay, now let's look at a standard deck of 52 cards. So there's 4 suits, and each suit has an ace through king. So the probability of rolling a hearts. Well, there's a couple different ways to think about that, but if you're just looking at suits, you can look at just the number of suits. So there are 4 suits total, right? They all have the same number of cards. So the probability of rolling a hearts is 1 out of 4. Now, if some of these had different numbers, different number of cards, so it was a weird deck, then you would actually have to count. But since we all have the same here, we just say 1 out of 4. Now the probability of rolling is 7. Okay, so now we're looking at the numbers here. Each number has the same number of cards. So there are 13 numbers total. 7 is one of them, so 1 out of 13. Which of course you can find the decimal equivalent if you need to, just by dividing. Okay, it's the probability of drawing a base card. Okay, so again, if we're just looking at the numbers here, we don't care about the suit. Each one has the same number. So face card is Jack, Queen, or King. So there are 3 of them out of 13 total. Okay, now Ace of Spades. Now we're looking at a specific card. We're looking at both number and a suit. So now we have to worry about the entire deck. So in an entire deck, there are 52 cards. And how many of them satisfy that they're both an ace and a spade? Well, only one of them, so it would be 1 out of 52. Okay, so the probability of getting a red card. Okay, so now we're only looking at suits again. So of the 4 suits, how many of them are red? Well, hearts and diamonds are both red, so that would be 2 out of the 4, or 1/2. The probability of getting a 2 through 10. Okay, so this one is only dealing with our numbers. We don't care about the suit. So 2 through 10, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. So there's 9 out of a total of 13 numbers. Okay, so that's theoretical probability. Now, empirical probability, all this is relative frequency. It's saying, okay, if I'm looking at an actual data set, if I actually tossed a coin, or if I actually rolled a dice, or if I actually drew cards, this is what has actually happened. Okay, so we use this a lot with like insurance companies might look at this to say, okay, in the past, this is about how many times people have filed this claim, or this is the amount of time people normally get in this kind of accident, and so we use the past to help us predict the future. So that's what this empirical probability is for. So we look at something that actually happened. So the probability of that would be the number of times that actually occurred over the total number of times we did it. So again, it's just the relative frequency is the part over the whole. It's exactly the same, really. We're just calling it probability instead of frequency, and we're going to put it as a decimal instead of a percent. So example 4. Let's say we flip a fair coin 3 times and record the result. Then we repeat this 800 times. So I'm not going to say, I'm not going to write out everything that happened, but these are 4 events that could happen, either 0 heads, 1 head, 2 head, or 3 head, and this is how many times each of them happened. So in this case, we don't have to actually count the number, they give it to us. So probably getting 0 heads. So we look at what actually happened. So actually happened, we got 0 heads 98 times. So it'd be 98 times out of a total of 800. So we do 98 divided by 800, and we can get either the simplified fraction, which if you have this calculator, you can figure that out. You do 98 divided by 800, which gives you the decimal. But if you need the fraction, and I'm not sure how to simplify it by hand, what you can do is use this F to D button. So you hit second, and then this, and enter, and it gives you simplified fraction. So this would be 49 over 400. Or the decimal equivalent of 0.1225, and rounded to whatever they want you to round to. Okay, so moving on to probability of getting 1 head and 2 tails. Well, that happened 321 times out of a total of 800. And if we just get the decimal, this would be 0.4. So 40% of the time, I got 1 head. So probably of 2 heads was 288 times out of my 800 total, which the decimal is 0.36. So 36% of the time I got 2 heads. 3 heads happened 93 times out of my 800. So that was 0.11625. Or we can round it to 0.12. This one can also be rounded to 0.12. Okay, so if we add all 4 of those up, it does add up to 100%. So that's good, because we can cover everything. So if we compare that to what I think we found that one before. Okay, so this was a theoretical of flipping a fair coin 3 times. Is of getting no head, we saw was 0.125. This is actually pretty close. Probably getting 1 head, we got 0.4. This is 0.375. The probability of 2 heads, we actually didn't figure out. But they're probably getting 3 heads is this one, so 0.125, 0.12. So the empirical was pretty close to the theoretical, which is what it should be. Okay, example 5. An experiment consists of drawing one card from a standard 52 card deck. What is the probability of drawing a king? Now we haven't actually done anything, so this is theoretical. So go ahead and try to do this on your own and then come back and check it. So you're drawing a card from 52 card deck. So there's 52 total outcomes. What is the probability of drawing a king? Okay, so again, we don't really care about suit here. So if we're looking at numbers, there are 13 different numbers. So a king is only one of those. So the probability of drawing a king would be just 1 out of 13. Okay, example 6. The local weather forecast has been accurate for 15 of the past 27 days. Based on this fact, what is the relative frequency probability that the forecast for tomorrow will be accurate? This one they want a decimal rounded to the nearest thousandth. Okay, so remember this is relative frequency, this is actually happening. So we just want to say, okay, how many times has it happened in the past? So we want the probability that it will be accurate. So we want the number of times in the past that it has been accurate. So it has been accurate for 15 out of 27 days. So out of a total of 27 days, 15 of them were accurate. So we can assume that in the future, there will be a 15 out of 27 probability. But they want this to the nearest thousandth. So that would be 0.556. Okay, example 7. What is the probability of not rolling a 1 with a fair die? Okay, so we want the probability of not rolling a 1. Okay, so we can either count how many aren't 1, or we can say how many are 1. Oh, there's 1. So not 1, there should be 5. So we have 5 out of a total of 6 possibilities for rolling a fair die. So we have 5, 6, and they want a simplified fraction, so we just leave it as 5, 6. Okay, example 8. So what is the probability that a 69% free throw shooter will miss his next free throw? Okay, so they want the probability that he will miss. Okay, so that means we need to know how many times he's missed over the total number of time. We don't actually have those numbers, but we do have this probability. We have the probability that he will make it to 69%. Okay, so in the past, he's made it 69% of the time, so we can assume that in the future, he will make it 69% of the time. So the probability that he will miss has to be everything that is not this. So we have 100% minus the 0.69 to get 0.31. So the probability that he makes it is 69%, which means on the flip side, the probability that he miss will be 31%. Example 9. The following table gives a gender and political party of the 100 delegates at a political convention. Suppose you encounter a delegate at random. So we're just going to pick someone at random out of all of these. So we have 100 total, 100 people total. So what is the probability that you meet a man? Okay, so we can't just look at like women and men and say there's a 50% chance, because there aren't the same number of men as there are women. So for the cards, we could do that because there were the same number of each number of each card, but because there aren't the same number of men as women, we can't just say 50%. So what we do is we need to see how many men are there. So we do 28 plus 16 plus 4, and we get a total of 48. So there's 48 men total. So the probability of meeting a man is going to be 48 out of the total of 100. They want a simplified fraction. So 48 over 100 simplified is going to be 12 over 25. Okay, what's the probability that you meet a Democrat? Okay, so we need to know how many Democrats there are. Well, there's 25 women and 16 men Democrats. So you do 25 plus 16, which is 41. So we have 41 Democrats over the total of 100 delegates, which is already simplified. Okay, what's the probability that you do not meet an independent? So if we don't want an independent, that is going to be, so the probability of getting an independent plus the probability of getting not an independent, because those are two opposites and they encompass everything, that's going to have to add up to 1, right? So we know the probability of not independent, if we subtract the probability of getting independent from both sides, then the probability of not getting independent is going to be 1 minus the probability of you are getting independent. So the probability of getting independent, so we have 10 independents total out of a total of 100. Or you can think of it as saying there are 10 independents, which means there are 90 otherwise, right? So that's 90 over 100, which simplified is going to be 9/10. Okay, so what is the probability that you meet a male Republican? So I want a male and a Republican. Okay, so Republican males, there are 28 of them out of a total of 100. Simplified would be 7 over 25. Okay, so what is the probability that you meet someone who is not a female Republican? So someone who isn't a female Republican. So we have 21 female Republicans. So if 21 are female Republicans, that means I have 100 minus 21, just 79 that aren't. So 79 out of 100 that aren't, which is already reduced to as a simplified fraction. Now again, so you can find it that way, or you can think of it as this way. So say this is 1 minus the 21 out of 100, which would give you the same answer. So you can either look at it after the subtraction, or after like dividing by the 100, or you can do it before you divide by 100. And when you do this, if you're not comfortable with subtracting fractions, you do 1 minus 21 over 100, it'll give you 0.79, and then you can change it to a fraction by taking the second FD to get 79 over 100. So either way will work. Okay, now let's talk about odds. Odds are a little bit different. When we talk about odds, we're talking about a ratio. We're not talking about a percentage. We're just talking about a ratio. We want to compare the number of successes to the number of failures. So all the things that satisfy our event versus the things that don't satisfy the event. So if you say for an event, you're going to have the number of successes first. So for means you want what does satisfy it first, and then the failures. If it's against an event, you want the ones that don't work first, and then the ones that work. So this first one is going to match that word there. So example 10, if we want to find the odds for and the odds against the event rolling a fair die and getting a 2 or 3. So we need to know the number of times we roll a 2 or 3, and the number of times we don't roll a 2 or 3. Okay, so rolling a fair die and getting a 2 or 3, so that's 2 options out of a total of 6. And the number of times we don't roll a 2 or a 3 is going to be the other 4. So we have your odds for the event, so something that does happen, or that does make it happen, is 2 against the 4. But then you see that there is a common factor here between 2 and 4, so we're actually going to simplify it to 1 to 2. Divide both numbers by 2 to get 1 to 2. Okay, so the odds against the event, now we're going to want the ones that, where we don't get the event first. So ones where we don't roll a 2 or a 3, so that's 4. And the ones that do happen is 2. And again, there's a common factor here, so we're going to divide both numbers by 2 to get 2 to 1. So notice the odds for and odds against are going to be the same numbers, they're just flipped, because you want to put the right one first. Okay, example 11. Of the 47 plays attributed to a playwright, 20 are comedies, 16 are tragedies, 11 are histories. If one play is selected at random, find the odds against selecting a comedy. So we want the number that we select for comedy and the number that are not a comedy. So it says 20 of them are comedies, and there's a total of 47. So we have 27 plays that are not comedy. So 16 plus 11 is 27. 47 minus 20 is 27, so we're good. So 20 are comedies, 27 are not comedies. This is the odds against, so we want the not comedy first, so we say 27 and 20, and there are no common factors here, so we just leave it as 27 and 20. Okay, example 12. So a rack of 15 billiard balls is shown. If one ball is selected at random, determine the odds against it containing a number greater than or equal to 7. Okay, so our success here is going to be having a number greater than or equal to 7. Okay, our failure is going to be any number less than 7. Okay, so we're going to, because it's against, we're going to put our failures first. We need to know how many of each there are. Okay, so there are 15 billiard balls, they're numbered 1 through 15. So the number is less than 7, so we have 1, 2, 3, 4, 5, 6 numbers less than 7. 15 total, which means there's 9 that are 7 or more. Okay, so the odds here, we can put the number of failures first, that is 6. The number of successes is 9. Now there is a common factor here of 3. So this can be simplified to 2 to 3. So the odds against containing a number greater than or equal to 7 is going to be 2 to 3. Okay. So the difference between odds and probability. So like I said, odds are going to be a ratio of success and failure. The probability is going to be a percentage, or it's going to be it's a fraction, it's a percentage, it's a decimal, it's a part over whole. It's not just comparing two numbers, you're actually finding a value here. So you can go from one to the other, especially from odds to probability, because this bottom here, the total amount that you have is always going to be the sum of your successes and failures. So let's look at example 13. Casey's going to wear a gray sport coat and is trying to decide which tie he should wear to work. In his closet, he has 33 ties, 19 of which he feels go well with the sport coat. If Casey selects one tie at random, determine the probability and the odds of the tie going well or not going well with the sport coat. Okay, so the probability that the tie will go well. So the probability to go well is going to be the number that does go well over the total number of ties. So we have 19 that goes well over a total of 33. So that probability is going to be 19 divided by 33, which as a percentage is 0.58. Okay, the probability the tie will not go well. Well, there's 19 of them that do, which means the other 14 of them do not. So 14 of them do not go well with the tie. So 14 divided by 33 is 0.42. Also note that this is 1 minus 0.58. Now the odds. So here we have like a decimal or a 58% chance, 42% chance. For the odds, we're only concerned about the numbers 19 and 14. the odds against the tie going well. So we want the ones that don't go well first, which is 14, to the ones that do. And there are no common factors here. The odds in favor means we want the ones that do go well first, which is 19, to the 14 that don't. Okay, so example 14, if the odds in favor of Chris winning the election are 92, then what is the probability that Chris wins the election? Okay, so this is the odds in favor, which means the 9 is going to be my success and 2 is going to be my failure. So the probability that he wins, that's the probability of success. So there are 9 that happened where he did win, out of a total of 11. So if 9 succeeded, 2 failed, that means there was 11 total. So the probability that he wins is 9 over 11, which as a decimal is 0.82. Okay, so the probability he doesn't win were the 2 failures out of a total of 11, which is just going to be 0.18, or 1 minus 0.82. Okay, so last, just a little spiel about the lottery. Lottery is completely random, unpredictable, and the odds of you actually winning is so small that it's not really worth it, in my opinion. I mean, you can read this if you want, but I don't suggest playing the lottery anytime soon. But that's a whole other story. So that is 7A.